Let's summarize whatever we have learned in this particular chapter. All right. See, when I say chapter, I'm going to summarize only the derivative part of this particular chapter. All right. Now, when we started with the derivative, we started off with the basic rules, that is product rule, quotient rule, and chain rule. Correct. Now, whenever you have any function, you need to apply the product chain rule or the quotient rule, depending on how the functions are present. Right. So when I talk about the function, now we are going to summarize what type of functions we looked into this in this chapter and how are you going to differentiate that one, as in how did you differentiate, right? So the first type of function what we discussed was implicit function. Implicit is where the x and y, both independent and dependent variable, are going to be together, right? Like sine of xy types. Now whenever you have implicit function, so you differentiate and then take the y dash value on one side and the remaining terms on the other side. Then if you segregate them, that's how you are going to get the value of y dash, or in the word, in other sense, dy by dx. Correct? So these are implicit functions, like both the dependent and independent variables are together. Fair enough? Now after implicit function, we looked into the inverse trigonometric function. So every time you have an inverse trigonometric function, you are going to convert this into trigonometric and then differentiate it. Correct? So every inverse trigonometric function like sine inverse x, cos, cot inverse, secant inverse, whatever it might be, they all have a particular derivative, right? So you guys need to understand how to differentiate them. Fine. So this is the inverse trigonometric function. Next is the exponential function. See, when we talk about exponential, that's e power something, isn't it? So let it be e power x or let it be a power x. Suppose if you have e power x, then the derivative is going to be e power x itself, right? A power x is going to become a power x log a. This is the derivative of these two. So these two marks the basic exponential function. And every derivative, whatever we are going to do on exponential, it is going to be like this: e to the power of 5x or e to the power of x square, where you are going to apply the chain rule concept. Correct? So exponential is this. Then we have the log function. Now, log functions are where you're going to take log on both the sides, both LHS and RHS. And once you take log on both the sides, under what situations you need to take the log? When you have a function to the power of function. Like if you have cos x to the power of sin x. To differentiate such functions, you need to take log and then apply the laws of logarithm. Suppose if you have log of AB, that's log A plus log B. Suppose if you have log of A by B, that's log A minus log B. Or if you have log A power B, it's B log A. These are the three major logarithmic rules what we use. Now, once you apply these laws of logarithm, then the function is going to get simplified. Right? Once the function gets simplified, then differentiate, get the value of y dash. This is one type. Sometimes you will have the sum where you won't be able to apply the log directly. Like you can have cos x power sin x plus sin x power cos x. You can't just take the log directly. So separate the two functions. Like cos x power sin x is one function, sin x power cos x is one more function. Take these two functions separately and then apply log and you can get the answer, right? So these are the two types of problems what you have in log functions. After log, we discussed about parametric function. See, when we talk about parametric function, so what we are going to understand is that you are going to have a function, but you are going to have another parameter, correct? So if you have x, x will be in terms of t. If you have y, y will be in terms of t. So if you need dy by dx, then you take dy by dt separately, dx by dt separately, and divide one by the other. That's how you are going to get dy by dx. So all parametric functions are like this itself. Either you will get in terms of t or you'll get in terms of theta. All these parametric functions you have to differentiate in the same way. All right. Once parametric is done, then we moved on to the next part, that is the double derivative or second order derivative. In second order derivative, you differentiate it once, you differentiate it again. It's going to be d square y by dx square. Right? So in the second order derivative, you have problems, but mostly they are proofs. Correct? Mostly they are proofs. So for all the second order derivative, you need to show, you need to prove couple of things. Fair enough? So after double differentiation or second order derivative, the last part what we discussed is the mean value theorem. So in which we have two, the Rolle's theorem and mean value theorem. Rolle's theorem, you have a range A and B. Now within that range, you have a point C where the slope of the tangent at that point is 0. That's when we say f dash of C is 0, where C is belonging to A comma B. Like basically, C is between A and B. This is Rolle's theorem. Now when it comes to the mean value theorem, see in MVT, again you have a function. So you have 2 points A and B, in which we have f of A and f of B, correct? F of A and f of B are 2 points on the function. We join them, that's going to become a secant. So that secant has a slope, isn't it? So once that secant has a slope, we have a point C between A and B in such a way that if you write a tangent at C, that tangent and the secant, they have the same slope. In other words, the tangent at C and the secant between A and B, they are parallel to each other. Right? So mathematically, f dash of C is f of B minus f of A by B minus A. Correct? So this is the mean value theorem. Now, this summarizes the entire chapter of continuity and differentiation.